Okay, here's our examples video for 10.5, and we're going to look through these 9 examples, and they use kind of a mix of ideas from the notes. And again, much like the previous section, all the ideas are really mixed together as we're solving. So in exercises 1 through 3, CD is tangent to the circle. And again, tangent means it just touches the circle once, and we're going to find each indicated measure. So first off, angle ABC. That's actually asking us to do a very, very old skill. So angle ABC, that is the angle on a line that is directly next to the 70, the ABD. So the angle ABC, so going from A to B to C, that has to add with 70 to be 180 degrees. So they're supplementary, which means we've got to do that angle we don't know. So angle ABC, I'll just write plus 70 has to equal 180. So I'm going to subtract the 70 from both sides, and then that means my angle measure, minus 70 minus 70, my angle measure is going to be 110. So angle ABC is going to be 110 degrees. And that's just using supplementary angles or a linear pair. Arc AB, so that's this arc right here. That is the first idea we encountered in the notes that is saying the angle is half of the arc, which means the angle is the smaller piece, the arc is the bigger piece. So if the angle is half of the arc is going to have to be 140 degrees. 70 is half of 140. Or you can think about what we did there was we took 70 and multiplied by 2, and that got us to 140 degrees. And if you were to work backwards from there, you divide the 140 by 2, you'll get the 70, which is our angle measure. And then angle or arc AEB, so that's the big arc since it goes through the 3 letters. So let's see, let's grab a different color here. So let's go arc AEB. If we're looking for that thing, that's going to be double this 110. So same idea or same thought process. 2 times 110 is 220. And just as a quick reasonability check, my green number and my red number, when I take those two and add them together, that should give me the entire circle. 220 plus 140 is 360, and that better be true. So that works here. That's going to give me my 360 degrees in the circle. So this is just a quick check that what I was doing makes sense and works in terms of what circles should be. So that's questions 1 through 3. Questions 4 and 5 both relate to this second picture. And actually, I'm going to jump back and use red again. I like red. I'm not sure why. So they're saying ADB. So that's arc ADB. So arc ADB, that goes from here all the way down to here. That's 220. They're also telling us angle B right in there is 21 degrees. Oops, 21 degrees. So I'm just going to label in what we know. And then we're going to find the indicated measure. So then they're asking us to go measure A to B and the arc. So arc A to B, that's actually the arc that I haven't used the red squiggly on. So we did arc ADB. That was this red squiggly line all the way here was 220. Arc AB, the rest of it then would be 360. That's the whole circle minus 220, what we used up, gives me 140 degrees left over. And that's just what remains in the circle. So that's 140. And then what we're asked to do is find angle ACB. So ACB, that's this exterior angle. And I'm going to switch over to use a black pen. So that's ACB. That's this angle. And you know what? I bet I could do a highlighter on that deal. That's this angle right here. And it lies outside the circle. So that thing lies outside the circle, which means I need to take this 140 that I just found, subtract whatever the arc is from A to D. And I don't know that one. So I'm going to have to find that. And then I'm going to divide by 2. And that was one of the ideas that we talked about in the notes, is you're going to take the big arc minus the little arc and divide by 2. So when they meet on the outside, we do big arc minus little arc divided by 2. I don't know that little arc though. So that little arc that goes from A over to D right here, I don't know that one. So I have to use this 21. That arc that goes across from an inscribed angle. So that angle is an inscribed angle. and it's got an intercepted arc that's going to be double it. So that was in the previous section. We're going to take that 21 and we're going to double it to get that arc length. So that's going to be a 42. So I'm going to take that 42 and plug it in here. And again, that's relying that you have that information from the previous section. So 140 minus 42 would be 98. And then 98 divided by 2, which we're dividing by 2 because they're asking us to find an angle measure, ACB. So I'm going to take 98 and divide it by 2, and that's going to be a 49-degree angle. So there's our 49 degrees. And that's the angle from A over to C and down to B. Okay, so finally we're going to look at 6, 7, 8, and 9. Each one of those has its own picture, and in each case they're asking us to just find the value for the variable, so the value for x. So let's look at what's happening on each of those. So it looks to me when I'm seeing this that, oops, there we go, that I've got the first two, I've got the chords are crossing, or the lines are crossing on the inside. So inside means I'm going to be adding and dividing by 2. And then in 8 and 9, my chords are crossing on the outside, so they're going to be subtracting and dividing by 2. So that kind of highlights the two differences we're seeing. Question 6 being much more straightforward than question 7. So let's start with question 6. The way you find an angle when you have the lines crossing on the inside is you add these up, the arcs that are associated with it. So this is number 6. I'm going to add those arcs up, 92 and 50, and I'm going to divide by 2. Well, 92 and 50, let's see, that's going to be 142. Divide that by 2, and that's 71 degrees. So x is 71, because I already put that little degree sign on there. So x is 71. In number 7, we're going to do much the same thing, but this one's going to require a few more steps. So they're actually asking for a bit more problem solving, which is good for you guys. We don't have the arcs associated with this angle. So we don't have the arc here, and we don't have the arc here, and we don't need to get them. What we do need to do is we need to go in here and get this angle measure. So I'll use a star for it, but it's D to the center out to C. So that star, I'm going to get the same way I just did in number 6. I'm going to take the 97, I'm going to take the 35 and add them and divide by 2. And when I do that, when you do 97 plus 35, let's see, we're going to get 120, we're going to get 132. So 132 divided by 2. Well, 132 divided by 2, let's see, 132 divided by 2 would be a 66-degree angle. That's what the star is. So the star is 66. Well, 66 plus the angle next to it, they both lie on a line. So if I take 66 and add it to 5x plus 14, so I add those two angles together, that needs to be 180, and that's just using the idea of a linear pair. We actually used that same idea, so I'll just pause for a second and scroll up here. We used that same idea on the very first problem to get number 1, where the two angles that sit next to each other had to equal 180 degrees when added together. And that's a really old idea. It's one of the first ones we did in this class. So if we add the 66 and the 5x plus 14, that's going to be 5x plus 80 equals 180. Subtract the 80 from both sides, and I guess I'll show that. So subtracting the 80 from both sides. And then I've got 5x equals 100. I'm going to divide both sides by 5, and x is 20. So this is a pretty heavy multi-step problem to get to the point where x is 20. That's all they're asking us to do, is just come up with the value for x. So x is 20. So it's a lot of work to get to a really small answer. And again, the way we did it was first found the star. We add and divide by 2. Then we're going to use that along with the 5x plus 14, and that's this step right here. We're going to combine those two to get 180 degrees because it's a linear pair. And then we'll solve through and figure out what x is. Okay, the final two questions, 8 and 9, we've got two lines that are intersecting on the outside of the circle. And so this is one of those where we're going to add up and divide by 2. I'm sorry, subtract. And I even wrote that subtraction sign in there. I'm glad I did that to catch myself. We just added up and divided by 2 and they crossed on the inside. Here it's the outside, so we're going to subtract and divide by 2. So the way that works is we've got three things. We've got a 38, that's our angle measure, and that is equal to the big arc x minus the little arc, 72 divided by 2. So we're being asked to solve this. It's saying the angle that's on the outside is big arc minus small arc divided by 2. So to solve this thing, I'm going to first multiply both sides by 2. And actually, you know what? I'll switch over just to show my steps in a different color. So I've got 2 times 38. Well, 2 times 38, let's see, that would be a 76. And then these 2's will cancel, and you'll be left with an x minus 72 over here. We'll add a 72 to both sides. And that means my x value is going to be 148. So x is 148. Which it's the bigger number, it makes sense. It's a larger amount, and that makes sense for what x would be out there. So that in this case, x is 148. We're going to be doing the same thing on number 9. We've just got kind of a more involved problem because we've got the 4x plus 8 and the 3x plus 2. So here we would say, okay, let's take 28, and that's going to equal, so the angle on the outside equals the big arc, 4x plus 8, I'll use the parentheses here, minus the little arc, 3x plus 2, divided by 2. And I know in the notes we presented it, or they showed it as 1/2 times. 1/2 times or combining the two and dividing by 2 mean the same thing. And I think from what I've seen over the years, students tend to gravitate a little to putting the two together on top and dividing by 2, but certainly you can do a 1/2 times this difference. And that's okay too, but I think seeing it this way has always made a little more sense in the past with students. So there's a couple ways we can do this. In this case, what I could do is just combine what I see up top. So I'm going to distribute that minus sign to both pieces. And I can kind of scroll up here. So let's see, on the top then I would have 4x minus 3x, well that's an x, so I'm combining like terms. And then 8 minus 2, that's 6. So plus 6. I get a much simpler statement up top. Now I'm working with something that's a little more bite-sized and easier to solve. Multiply by a 2 on both sides. Same step as the last time. Those 2's over here will cancel. And then 2 times 28 is a 56. And that's equal to x plus 6. And then I'm just going to subtract 6 from both sides. And in this case, then x is 50. And that's it. So that gets me my x value. And I'll write it up here as well. X is 50. So that's show the steps here. If I can grab hold of it. Oh, grabbing the wrong thing. There's my x is 50. So that's it. That is working through all the examples associated. What we'd like you to do now is try the practice problems on practice A for 10.5 and check your solutions, and then go on to tackle the homework.